Okay, just a few words about the format of these sessions for those of you who are new. These are recorded, and Makespace do put them up on YouTube in due course. So if you don't want to feature in the recording, then don't have your camera on, and if you speak, you'll be captured on the audio. So just so that you're aware of that. I run these on a kind of informal, interrupt me, ask questions kind of basis. As I said a few minutes ago, I'm not a professional CAD user, and there are undoubtedly many ways to do things, many of which I probably don't know. So where you spot me doing something and you know of a shortcut or an easier way to do it, please do jump in. I learn as much from these sessions as hopefully you do from me showing you what I've learned. So let me share my monitor. Hopefully you can now see my Solidworks screen with what looks like the end of a shed. I'll assume yes, unless somebody shouts
yes,
otherwise.
I can see the end of your shed.
Excellent. So what I wanted to look at this week, perhaps I should do a quick recap of what we've covered in the previous sessions. You can find the previous sessions on YouTube under the Makespace account. We did an introduction to the basics of modeling in SolidWorks in the first week, and then we looked at ways of constraining your model and sketches so that when you make adjustments, things change proportional to what you might want to happen. So for example, if you've got a hole that's 5 millimeters from an edge and 20 millimeters from the middle of your piece, then you could either constrain it based on the dimension to the edge or the dimension to the center point. And when you resize your part, your hole will move based on the constraint. So we did a bit on thinking about how to constrain things so that if you then do things like change the width, then your part will kind of, the behavior of how it resizes everything proportionally, it varies depending on how they constrain. So if you're interested in those areas, I encourage you to go and watch the previous sessions. What I wanted to dig into this week was ways of propagating information between parts. We did cover the whole area of equations last month, where you define essentially global variables, which are then kind of used in defining dimensions, so that when you change a dimension, when you change the variable, the dimensions that are defined in terms of it all change together. So if you've got lots of dimensions that depend on the width of a piece, for example, then you can define it as a variable. And then if you decide to change the width of the piece, it updates in all the dimensions that are referencing it. This week, I wanted to look at configurations. So configurations are a feature where you can define different variants of the same part, and it can work on a part level or it can work on an assembly level. So if I open up one of these parts, which is essentially a piece of wood, it's a fairly simple part. It's essentially a rectangle with fillets on the edges to represent a piece of wood that's kind of had the edges smoothed off. And I've given it a material, an appearance so that it looks like a piece of wood. If this is a kind of standard piece of stock timber, and there are a lot of different lengths which I want in my part, there's a number of ways that I can propagate all of that information apart from the length between multiple parts. The first of those is to actually create a kind of master part. And that's what I've done here. So you can see in the tree on the left that we've got a timber profile part, and then I've got a cut extrude. And if I open up that timber profile part, has it opened up the original? I think it's opened up in place. Let me go and find the actual original file. It looks like even this one's been edited, but no, that's fine. So this is the original timber profile that I created. This is actually 50 by 50, not the one we were just looking at. But you can see that essentially we created, if I roll back the sketch, we created a simple rectangle, well, a square sketch in this case, 50 by 50, and then extruded it to the length of the, in this case, I did the length of the timber as sold by the timber yard that I was buying it from. So they were 3.6 meters long. So that's my basic piece of timber as it comes from the timber yard. And I put some fillets on just to kind of illustrate that actually the ends aren't totally square, but are slightly rounded because it's planed and maybe sanded. Now, if I want to then make different lengths for a construction of timber, the first option I could use is I could create a new part. And the first thing I want to do is insert that master part, that timber profile. Now notice it's coming grey, i.e. with the default appearance. That's because I'm going to undo that and do that step again. So on the insert menu, I do insert part. And before I actually click to select it, I need to scroll down and say propagate visual properties from original part. Now I can place it. And now you see it's brought in the appearance. I'm not going to put any mate settings in this case because it's not got any other parts. But if I had other parts already in here, then I could associate it with them by defining mates, similar to how you would in an assembly. Oh, now for some reason it's insisting on me putting in a mate, even though I haven't. That's probably because I added the part and then removed it. So what I'm going to do is close it and just start again, rather than mess about with. So I did file, new part. I did insert part and inserted my timber profile, remembering this time to include the visual properties. And this time it is asking me for mates. So maybe that's changed slightly. So what I'm going to do is I'll attach it to the origin. So if I select the origin and I select a point on my part and say coincident, add that, then it's happy it's got a mate. That part's now located in space. So this is my stock timber as it comes from the timber yard, but I don't want it to be this long because I'm going to cut it down to size. So what I'm going to do is I'm going to do a cut extrude. Now, normally when you do a cut extrude, you're kind of selecting a shape that you're going to remove to kind of remove some material. So I'm going to use the technique of using a face to define my sketch. So I'm going to select the face before I do the cut extrude. And then I'm going to just select convert entities, which turns that face into a sketch. So you can see it's instantly fully defined because it's defined as that face. So I can exit the sketch straight away. And now at this point, I could say, well, how much material do I want to remove? I'll remove 2 meters of it. And if I do that, I end up with kind of what's left. But that's a bit unintuitive for how you'd normally think, because the dimension is actually defining how much I've lost. So instead, a better way that I've come up with is to do an offset cut extrude. So instead of cutting from the sketch plane, I'm going to cut from a distance offset from the sketch plane. And if I want my piece of wood to be 1400 millimeters long, 1.4 meters. I'll offset that far, and then I'll make the extrude go through all, and I need to flip the direction of the extrude. Sorry, I need to flip the side of the cut, I think. Sorry, flip the offset. So I want the offset was coming out into the screen. I want it to go along the wood. So I've said to basically remove all the material beyond that point. And there we go. I've ticked too many things. So I'm saying cut away everything from that offset distance onwards through everything. So what I'm left with now is a piece of wood that's the length of my dimension. So that kind of makes a lot more sense. And now I can save that part. Now, the advantage of having done this is that if I was to then, let's say I also want a piece that's 1800 long. Sorry, Zoom is messing with my mouse and has made my mouse disappear. Let's try that again. There we go. I think I've got Zoom interfering with. There we go. So I double clicked on dimension and I'm going to change it to 1800. So now I've got a piece that is 1800 long. And you can imagine that I could build up lots of parts like this. So I'll save that one also. Call it timber 1800. And we could then go and build some sort of assembly. So let's make an assembly from our part. And insert two of them. And I'll insert one of the other ones, which is not currently open, because I did save as. And then I'll define some mates. So I'll say I want this face to be aligned with that face. And I want this end aligned with this face. And I want the front faces to be aligned. And I'll also just define mates. So everything's nicely lined up. So I've got an assembly that's made from these two different parts. I've got two instances of one of the other. And the advantage of having gone through that process is that if I later decide that my timber is actually not, I'm just going to save a copy of this so I don't completely destroy my other project that I borrowed this from. Let's say that my piece of timber actually was a different size. Turned out that the timber yard gave me the dimensions before planing. I seem to be having real problems with the dimensions. Just give me 1 second. There we go. So if it was actually 45 by 45 and maybe the fillets were much more pronounced. I've made that modification to my master part. And now if I go back to my assembly and click rebuild, then all of those changes, it was a bit subtle because I didn't make that drastic a change, but we can confirm by using the measure tool. If I go to evaluate, measure the distance between those two edges, is 45 millimeters. So all of my pieces of wood in my whole construction have picked up the change. So that's the kind of first method which I've come up with for doing these derived parts. If anyone's got questions about anything or does things in a different way, do feel free to kind of interrupt and jump in. Now I'm going to show you a second way that you could do this. If I go back to one of my pieces of timber, an alternative way to do this, I've got a dimension in this timber, which is the length. If I double click on it, you can see it's actually got a self-assigned name, but I could rename that just to make things a little bit more meaningful. Call that dimension length. I can now go into configurations. I'm going to save a copy of this so I don't. When you've got parts open that are used in other assemblies, you get these options where you can either save the file with a new name and have the assembly pick up the reference to the new name, or save it as a copy so that the assembly that used that part is not updated and remains attached to the old file. And you can choose whether you want that file to be open or to just kind of save a copy on disk but carry on working on the old file. So I'm going to save as a copy so my old assembly doesn't get updated with the file name change. And I'm going to open the copy and I'm going to call it timber 2x2, because even though it's 50 millimeters, people commonly refer to it in the old inches. So I've now got a piece of timber of a specific length with a dimension defined. But if I go to the configuration manager, which is this third tab on the little tab pane on the left, you can see I've got a default configuration here because I've just created a part. But what I can do is I can add a configuration. Now I can derive it from that first one, or I can just create a new root level one. And I'm going to call this one 2 meters, 2M. So now I've got a default configuration and a 2M configuration. If I select the 2M configuration and go back to change my dimension, you'll notice that on the end of the dimensions dialog, there's an option to say, do I want to apply the change I'm about to make to all configurations, specific configurations, or just the configuration I'm editing at the moment? So I'm going to change it to say just this configuration and change my length to 2 meters. So now I've got a part that's 2 meters long. But if I go back to the configuration editor, you can see that I can double click and go back to the original, which was 1800 long. So when I toggle between the configurations, that dimension change is different in those two parts. So what I could do now is, again, build an assembly from my part. So I'll do make assembly from part. But you'll notice now that when I put my part in, I'll just remember to, okay, we'll come back. I've got the option to pick which of the configurations I want. So if I want the 2 meter long part, then I can bring that in, and then I can insert my part again, but this time insert the default, which is the shorter one. And once I've got my parts in, if I select them in the tree on the left, then I can actually change which configuration is in place for each instance. So that's another way to apply dimensions, multiple variations on a dimension to an individual part. I can go further with configurations. I could, if I go back to my original piece of timber, we've also got the material type. So this one's currently set to cedar. If I edit material, I might like to have a piece of oak. And there's a config button here. And when I select that, again, I get similar kind of options. Do I want to apply this to just this configuration, all configurations, or specify which configurations? So I'm just going to cancel out of this before I make that change. Go back to the configuration manager. I'm just going to show why that renamed it. The default configuration won't let me change the name. Okay, the default, I'm going to create a new derived configuration and call it 2 meters. I can't have a, right. I'll call it cedar 2 meters, just so the names don't clash. So you can see you can build these up in a tree. And I'll create a 1.5 meter cedar. So my 1.5 meter cedar be 1.5 meters long. My 2 meter cedar two meters long. And then this configuration here, there is a way to rename these, and rename tree item. Just going to call it oak. Let's see if I can rename default to cedar. So now I'm going to select my oak and go back to change the material. So I'm editing the material, I'm going to configuration, I'm going to say, just apply it to this configuration. So there's my oak. There's my cedar. The difference is a bit subtle. If I zoom in, it's a little bit more obvious. So the visual appearance is changing. And now I can create some more derived configurations. So I could call this 1.5 meters. Like 2 meters. And then I need to go through and make sure that I've updated my dimension in that configuration.
So just to check that I'm following.
Yeah.
So you're essentially you're creating these parts, and then these are sort of being stored in a kind of a cache, I suppose, and then you can kind of call on them to make assemblies.
Yeah, they're associated with the part and saved with the part.
Right.
So
okay.
the part has multiple configurations, and you can see them all on the Configuration Manager tab.
Right. Yeah. Okay.
So I can now flick between my 2 meter and my 1.5 meter cedar and oak configurations.
Right. Okay. So yeah. So when you sort of come to make an assembly, you've got them all there, and you can kind of just choose from them instead of having to sort of
Exactly. Yeah.
time. Okay. All right. Yeah, that's cool. Just making sure I'm following.
So if I go back to this assembly now, you can see that they're all available on the menu here.
Oh, okay. Yeah.
Above the part. So I could have a 2 meter piece of oak and a 1.5 meter piece of cedar, but I've only actually got one part file in the assembly.
Ah, right. Okay.
Yeah.
Efficient. Yeah.
So any change I make to that part will be reflected in the assembly because there is just the one part.
Cool.
So it's an alternative way. The derived part works well when you've got kind of quite complex parts, because to kind of change everything in configurations is, I often start with a kind of master material part. I could use configurations, and I'm really undecided as to which is the best way because I've only kind of discovered both of them fairly recently.
Right.
Now, you could see it was quite laborious building up all of those different configurations, and there is a much better way. So I'm going to start a brand new part, and we're going to look at some other design principles along the way. So I'm actually, in this case, going to make a sketch derived part. So before I actually create the part itself, I'm going to create a new sketch. So I've gone to the Sketch tab. I've clicked on Sketch. And I'm going to create a sketch which is just made up of construction lines. And what we're designing here is going to be a hex bolt. So I need my bolt to have a certain length. And I'm going to make my line construction geometry, which means it won't actually appear as a line in the sketch that's visible. It's just there for, I'm going to put a dimension on it. So my length of my bolt is going to be 35 millimeters. I need a diameter for my bolt. Because I want the dimension to be the diameter, I'm actually going to draw a line which represents the full diameter of the bolt. And I'm going to attach its midpoint to the end of this line by holding Control to click on the second point and saying coincident. I'm going to do the same thing at this end. So, and before I finish drawing the line, I can actually, I select the line tool, I can actually say for construction before I draw it, which saves me having to reselect it afterwards. So I select the midpoint, hold Control, select the end of that line, and say make those coincident. So that's snapped to there. My bolt is also going to have a head of a certain length. So I will put another line in. You'll see some constraints are automatically appearing. So the horizontal constraint has appeared here because I drew that line horizontally. So it's already constrained to be perfectly horizontal. And likewise, these have been constrained to be vertical. So if I dimension these, so the diameter of my bolt, I'm going to go for 4 millimeters. The diameter of the head, I'm going to go for 8 millimeters. And the depth of the head, I'm going to go for 4 millimeters. So that's fully defined. So everything is fully constrained. So I'm going to exit that sketch. And now I'm going to use that sketch as the basis of building up my model. So for my bolt, the first thing I need is a circular shaft. So I'm going to do an extruded boss base. That's interesting. Let me come out of that. So I drew things so that the right plane was actually where my head was. So I can use the right plane to put my extrude on. And as I drag this, I can actually, if I stop just over the dot, you can see it's automatically dropped a constraint onto it. Now, for some reason, it's underdefined. I'm not quite sure why, because I thought that would fully define it. It's because the center point didn't actually attach itself to anything. So I need to select the center point of my circle, the point on my line, and make those coincident. Right, now it's fully defined. So you can see that that circle is attached essentially to the end of my line of the bolt. And I want the head of the bolt to go in the opposite direction. So I'll make it move that way. And I want it to actually move to the tip of this point I put on the sketch, because that's the whole point of that point on the sketch. So you see, as I've selected it, it's actually snapped to it and changed the direction to be up to vertex. So there's the head of my bolt, and its dimensions are all defined through the sketch. Now I'm going to do the same with the shaft of the bolt. So I'm going to, I'm not sure quite what it's picked up, because I had a face selected, it automatically picked the face. So that's no problem. We will extrude from there. Again, select circle. This time I'm just going to bring the circle out to a certain distance, but then I'm going to select the circle and hold Control and select one of these points and say coincident, and it will snap that circle to the distance of that point from the center. So that's now also fully defined. So when I exit the sketch, I can now select the endpoint here again, and you can see it's switched to go up to vertex to that point. So that's my basic bolt. I'm going to save it before we go any further. Keeping it very, very simple just to kind of illustrate the principles, but we can extend it further in a minute. So what I didn't do when I was playing with this sketch is give my dimensions sensible names. So let's do that now. So if I double click on each dimension in turn, that one I'm going to call the length. That one I will call the diameter. I'll call head diameter. That one I'll call head depth. So they're a bit more descriptive. They'll make more sense in the configuration manager. So obviously I can change any of those dimensions and my bolt will change accordingly. So for example, if I make that one 25 long, then my bolt shortens to have a 25mm thread length. Now where the magic happens is if I go into the configuration manager and right click on the top head. So it's not on the right, it's in insert. Go to the insert menu and there's tables item near the bottom, and I'm going to insert a design table. And I'm going to say auto create, and it will hopefully do the intelligent thing. So it's asking me which dimensions do I want to put in the design table, and you can see my sensibly named dimensions are now all showing up. If I had other dimensions in my sketch, they would also appear here, but for now I've just got those 4. Everything's derived from them. So I'll select them all, click OK, and you can see that I've got a spreadsheet-like table which has appeared with my configuration. So now I can actually define some other bolts. So I could change my default. I'm not quite sure whether it copes with the default being renamed from under it. I will click off the table, it disappears, and I'll rename default to describe what we've got. So if you remember from our dimensions, we're 4mm diameter and we're 25 long. So essentially this is an M4 by 25 bolt. So let's make that M4 times 25. So if I open up the tree to see my design table, right click on it, I can say edit table. Now it's picked up that there's some other things going on. First of all, that there's a configuration that wasn't in the design table and it's asking, do I want to add it? And I do. It's also noticed that there are other parameters. So it's offering me, do I want color to also be a parameter? So I could actually pull kind of some of my appearance settings. And I can, if I don't want to always be bothered by being asked the same question, I can tick to say, so if I do want to have this choice of these color options again, I want to tick this. But if I don't tick it, then anything I don't select here isn't going to appear again. So you can see now that my bolt name, and I'm not sure why it's decided to rotate it like that. So I might want M4 bolts of various sizes. So let's have an M4 times 15, an M4 times 20, M4 times, we've already got 25, so I'll have an M4 times 30. And then I'll also have some M5 bolts times 20. Now, these are just names at the moment. They don't bear any relationship to what sizes they have. I have to put those sizes in. So all of my M4 bolts, I want to be 4 millimeters diameter. My lengths, I want to match the length I put in the name. And then I can decide for my different sizes of bolts, probably the head diameter and depth is going to be the same regardless of length. So let's have that for an M4 bolt. But for an M5 bolt, let's make the head slightly bigger diameter. And the head could still be 4 millimeters deep, or I could maybe make it 4.5. Notice that the toolbar that you see at the top here is the Excel toolbar. I don't know whether this works if you haven't got Excel on your computer that you've got Solidworks on, because I haven't tried that. But I can use all of the Excel kind of features to, so for example, it's annoying me that all of these have been rotated. I don't quite know why. So let's see if I can. And I can also copy formats as you can in Excel. And okay, so I've defined a set of configurations that describe the dimensions I want for each configuration. As soon as I click out of the design table, I can click the big green tick over here just to be really sure. It's telling me that it's generated some new configurations. And now you can see my configuration editor has automatically populated itself. And if I double click on different configurations, so there's my really long M5 bolt, my short M5 bolt, my long M4 bolt. So you can see that each of these has now got its own configuration. We can obviously add more details to this, and they can all be dimensionally driven. So let's put a chamfer on here. 0.5 millimeter, probably be about right. Now, because I've added a new feature which has its own dimension, i.e. that chamfer had 0.5 millimeter as a dimension, if I go and edit the design table, notice that I've also now got that option to bring chamfer in. So if I select that, it's added, interestingly, it's added chamfer state and not the chamfer dimension. Not quite sure why it's done that. And it's not going to let me undo it. I think chamfer state, because I think when I added that chamfer, let's go back to the it is applied to all configurations. edit table. I'm not quite sure what I've done there. I was expecting the chamfer dimension to come in, but it hasn't. What I could have done is maybe added the dimension to define the chamfer to the sketch, so that I would have had a named dimension. It would be more critical if we're going to put our socket head into our screw, where we would be doing an extruded cut on that face. Nice hex socket for our Allen key. Now, there's two aspects to the hex socket. There's how big is the hex and how deep is the hole. And to keep things simple, I'm going to go back into this sketch and I'm going to add the information that I need here rather than in the so I want to extend this out to there. So my head radius cancel that, because it would be more sensible to join it to the middle. So I'm drawing the center point to there. Make it a construction line. Socket size. Socket depth. Now, if I go back to my cut extrude, edit my sketch. I'm going to take the center point of one of my flats and attach it to the end of that sketch line. So that's now fully defined that sketch. And my dimension is describing the flat to flat size of that hexagon. And then if I go and edit the cut and select my point, it will snap to that depth. So now I should be able to go back into, so I've defined the depth of that socket to be based on this line of my sketch, and the flat to flat distance of the socket to be based on that line. So if I go back to my design table and edit the table, I will hopefully get offered the option that hasn't Show unselected items again. I think I can probably type them in. We'll try that. Socket depth. Sketch 1. Hopefully it will pick up those references. And we'll make it. No, it's got, so because I've deleted what was in those columns, let's put a constraint on. Let me try and delete the whole column. There we go. So I'll make my socket slightly bigger on the drive, and it can be 4 mil deep. Yeah, I saw it change size, so I think that's worked. So if I jump to my M5, it's disappeared completely. So that implies that it's only applied that cut extrude to one configuration, but I did say all configurations. Maybe if I select them all. No, something has I've done something which is slightly confused it, and I don't really understand what. It did appear to pick up that change to the one configuration, but it hasn't applied it to all the others. So possibly the lesson is to get it right first time and put all the dimensions on before building the design table. There's definitely more to adding things to the design table than I understand here. But hopefully the principle of how they work has come across there. I'm going to shut it down. And open up a new project, just to show you some of this in action in a context of a bigger project. So with the license that we've got for Makespace here, we've got the Solidworks Student Edition, and it's missing the toolbox feature. If you have the professional versions, then you'll find in the design library that the toolbox will be populated, and in there you'll find huge numbers of fastenings, kind of nuts and bolts and the like. But we don't have the advantage of that in the student edition. So what I've done for my robot project here is I've created the common fastenings which I use. So you can see that I've got various fastenings here. Let's take, for example, a hex nut. I can manage to select it without it selecting something in the background. If I select it, you can see that I've got lots of different options of nut size, including a nylon and a metal version. So I can change that to be a stainless steel nut or a nylon one. And if I open up the part, you can see that I've got a design table. And my design table has picked up the material as well as the dimensions that define my nut. So works exactly the same way as what I've taken you through in the tutorial. And if we do the same for the hex, not the hex, the crosshead screw, which I've got here, I went all out on this one and I designed a number of different sizes and lengths. And there's quite a lot of dimensions in the screw. For some reason it's lost my, I think it's just that the design table is off the screen. There we go. There we go. So you'll notice I've got this column here. And what I've done is I've used a trick because this is Excel. What I can do is I can actually derive names from dimensions. So I've used the concatenate function to essentially build up a name from an M, then the value in D5, which is our screw size. So it's an M2, then an X, then the value in the length column, and then millimeters. Now, the reason that I've got these over here is that I discovered that if you try and put formulae in this configuration name column, it doesn't like it. So what I did was I designed my formulae here. I then dragged it down to autofill to generate all my names. And then I did a copy, selected this column, and did paste values to copy them over as static text. And that way I was able to, so I can easily extend my design table. So if I wanted, an M8 screw, I don't know what height an M8 screw head is. I looked these up on a fastener's website to get the correct dimensions. 15 millimeter, 20 millimeter, and then I can use Excel's autofill to. I want those to be the same, so I'll copy and paste those. And then I can just drag down my formulae that calculates my names, and then copy them, do paste values, exit my design table, and it added all those M8 configurations. And now I can double click on them. There's my M8 short screw, my M8 long screw. And you can see that I've modeled this screw very basically. I haven't bothered to put cosmetic threads on or anything, because for the purposes of my designing, they're just something for me to kind of put constraints to say that this hole is aligned with this shaft of this screw. I'm not going into the detail of kind of putting the thread on my bolt. Model things to the level of detail that you need for the purpose that you're going to use them for. What I have done, there's a lot of dimensions that you didn't see in the design table, which change. So for example, the crosshead size on my screw, if I go to an M2, is much thinner and smaller. And I did that by using equations. So you can see that when I defined this sketch that is my cutout, I've actually derived the dimension from the screw size. So as I changed the screw size variable in my equations, we looked at equations last time. So I've got various names. I've named the dimensions in my sketches, and then I've derived other dimensions based on those dimensions. So the head height in my sketch 1 times 0.62 gives me dimension 2 in my sketch 1. So things are kind of scale proportionally, all based off those few actual dimensions that I need in the design table.
One thing I've actually found helpful is that data sheets for parts sometimes do have equations you can just put straight into a CAD app. As in, when you're looking at a data sheet and you see there's only half the dimensions you're looking for, you might find there are equations for the others.
Oh, that's useful to know. I've not spotted that before. I've kind of used the catalogue listings to find out things like what's the diameter of the head of an M2 screw, so that I could put in something representative. Obviously, if you were doing something really engineering kind of specific tolerances where your screw head clearance was critical, you'd measure the diameter of the head of the actual screws you're using and not just pick some arbitrary M2 screw off eBay. But for the purposes of designing the kind of project that I was playing with here.
Timing belts is where I found it really helpful.
Yeah.
Yeah.
So we've gone over the hour. That was all I had planned to show this week. So I will open the floor to questions. If anyone has any questions or comments before we wrap up, I'd be happy to help.
Thank you, Footleg. Can I ask you a question?
Yes, of course.
Sorry if you covered this before. In your robot assembly there, does the bill of materials pick up your configurations? Can you find out easily how many M5 nylon washers you need to buy?
I think it does, but I've not played with bill of materials for a while. I can't remember.
It's okay. I won't ask you to do it live. I was just curious if you thought that might work.
I'm always up for a live demo. I can't remember where the bill of materials tool is. If anybody knows, shout out and we'll give it a go.
Is it? Can you get it on the context menu for the parts tree if you go right to the top of your assembly?
From there? Seeing it there.
Ah, it's hiding on your menu bar now. Bill of materials. Just left of.
Ah, yes, there we go. I knew it was somewhere. Let's go parts only and see what comes out. Display configurations of the same part as separate items. There you go.
That's exactly what I was wondering. Thank you.
So there's lots of options to do it different ways depending on what you want. But I think for what we've done, that would be go for a new annotation view. I have no idea what that is going to do. So we can attach it onto my drawing. Not sure if that's quite what we wanted, but so I've got 4 motors, 4 mounts on my motors, 4 wheels.
So then you can put the prices in and really scare yourself.
Yeah. It's broken down the Raspberry Pi into its individual components because the model of the Raspberry Pi I've got in there is all individually componentized. So yeah, so we've got 9 10mm 2.5, 2 20mm. So yeah, so that looks like that's worked. If you're wondering why there's 9 screws, it's because somewhere in here there's one missing. So somewhere I've deleted a part from a mirroring operation and I've lost one of my screws. So quite often when I'm building a model like this, rather than put every single, that bill of materials is really annoying in 3D like that. Let's see if we can get rid of it by undoing. There we go. Rather than adding every bolt individually and mating them all, where I've got symmetry, I often use patterns. So you can see I've done it with my hex standoffs, for example. So I've built this stack that's a standoff with a washer. I could have put the screw into that stack as well, but except that my screws are at different heights because of my roll bars. So I've left the screws out, but I've put the hex standoff and the washer, which just gives me the spacing that I need, is defined as something which I've then used a linear pattern to duplicate it up the robot. And then there'll be a mirror to mirror them across. And you can see with the mirroring, I have included the screws, except one of them has possibly got missed. There it is. So when I defined that mirror, I must have missed that screw off. There we go. Fixed my robot. I think, I'm not sure if it's the one that I've got in this robot. Excuse me.
Bless you.
This Raspberry Pi model has just got one configuration. I'll just show you another one because it's quite relevant to configurations. There's a Raspberry Pi 3 model, which we looked last week at where you can find some of these models. This one came off CAD, which is a great community website for sharing your CAD models. So if you need a Raspberry Pi to go in your CAD model, don't feel that you have to go and build one because someone's probably already done it, and CAD is the place to go and look for it. You can see this Raspberry Pi 3 model is very detailed down to individual components, but they've used configurations and they've got a light version where instead of modeling all the individual components, what they've done is put a photograph of the PCB instead. So the components, apart from the main chips, don't actually stick out from the board. It looks pretty, but it doesn't show you whether that resistor would clash with some part if you've got really tight tolerances. But because it's a lighter model, it's less computationally intensive, and so your sketch renders quicker, your models render quicker when you're on a slower computer. And if you're building a model to kind of explode, you don't get your Raspberry Pi exploding into thousands of tiny passive components. And they've got a configuration where They've got a pin header. And they've got one that says default, which also has the pin header. So maybe what they meant, it's the pin header, there we go, for the for this extra thing marked run, which I can't remember what it does on the Raspberry Pi 3B. So the default doesn't have that populated. So you can see you can do all sorts of things with configurations, hiding different components. I started off showing you the wall of a shed, which I've closed now. I was going to, we've run out of time, but I was going to show you how you can use configurations to essentially make modifications. So I've got two walls. This is going to be a chicken coop, and I'm going to have a door in it. So I might cut the hole for my door. So I have a big door for accessing the chickens to clean it out. And what I could do, there's no configurations defined yet, so that's just going to let me add a second configuration. Front. Make sure my door goes all the way through. And I can say only apply it to this configuration here. So now I've got multiple configurations. I've got this option to say apply only to this configuration. So now I've got two configurations. I've got my front where I've got a big door hole, and I've got my back where I haven't. Only I'd already defined it on the default slightly wrong. So now I've got a cut extrude that's different for my front and my back. So I think if I delete that, I think on advanced, no. No, so I've deleted it completely now, but you get the idea. You can kind of put different cutouts in your more complex part in each configuration, and then you don't have to redesign and duplicate the whole part. So if you make some other cosmetic change to things like the kind of framing, the battens, that'll apply to all your configurations, but the hole that you've cut out for one specific instance only applies to that configuration. Okay, any other questions or insights anyone wants to throw in the mix before we wrap?
No, just thanks very much for taking the time to explain. Really long time since I've looked at any configuration stuff, and I always want to use it, but never remember how to do any of it. So yeah, thanks very much for going through that with us. Yeah, you're welcome. I stumbled across it myself when I started creating mirrors of parts to go into assemblies. So I created quite a complex robot that had big kind of rocker bogie arm, and I wanted to mirror that, and so I used the mirror feature and discovered it had created mirror images of everything in all my configurations of my parts, and it got very, very complicated, and that took me down the rabbit hole of learning a bit more about them, and I found them extremely useful. Yeah, I think once it's just kind of one of those things, once you kind of get in your head how to do it efficiently, it's invaluable. Yeah, thanks very much. You're welcome. Okay, then the video will get published in a week or so. Normally it takes Simon to kind of cut and tail them and upload them. And we'll be back here next month. Same pattern. I think it's fourth Tuesday of the month. And
if you've got specific topics you'd like me to consider, then contact me through the meetup, and or find me on Twitter as Dr. Footleg, Dr. Footleg. Otherwise, I will dream up something to take us forward next week with some more SolidWorks. Not next week, next month.